Good afternoon, everyone. Once again, welcome back to Sharnavaseshwara College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer, Jagadish M. Okay. In last class, we discussed about your properties of Laplace transformation, that is change of scale, first shifting property, multiplication into t to the power n, and division by t. Okay, and also we solve some problems related to that your property number 4, division by t. Okay, today also I am going to take some examples related that property number 4. Okay, okay. The example is find the Laplace transformation of e to the power minus t into sin t divided by t. Okay, this is your next problem. First solution. First, we will write your given equation, that is e to the power minus t sin t divided by t, and we know that our Laplace transformation, sorry, our property number 4, division by t of statement is, there is Laplace transformation of f of t, Laplace transformation of f of t divided by t is equals to integration over s to infinity and your remaining Laplace transformation of that function with respect to s. Okay, so this is our given equation. It is Laplace transformation of e to the power minus t into sin t divided by t is equals to integration over s to infinity Laplace transformation of your remaining, that is e to the power minus t into sin t. Okay, with respect to ds. And you guys already know e to the power minus et and e to the power at. This is your property number 2, that becomes s tends to s minus of a. So here a value is minus 1, e to the power minus t is there, so a value becomes minus 1. So this function we will write as s tends to s of minus 1, that is s plus 1, where s tends to s plus 1. It means wherever we get the answer this function, on that we substitute s to s. Instead of writing s, we'll write s plus 1. Okay, so here your problem, that is integration over s to infinity Laplace transformation of e to the power minus t into sin t ds, and this function we will write as integration over s to infinity Laplace transformation of sin t ds into this function. It is s tends to s minus of minus 1. It is s tends to s plus 1. Okay, so this is you by your property number 2. Okay, this function I'll write again once more. That is integration over s to infinity Laplace transformation of sin t ds is equals to, sorry, is tends to where s tends to s plus 1, and call this is as equation number 1, because just we solve these functions. So what we get in answer to this function, on that we substitute this value. Okay, let's start this function, that is Laplace transformation of sin t ds, and you guys already know that is sin t. Laplace transformation of sin at is equals to a divided by a square plus a square. That is a value is 1, that is 1 divided by a square plus 1 square. Okay, this function I write here, that is integration over 0 to infinity, that is Laplace transformation of sin t is equals to, that is your value 1 divided by a square plus 1 with respect to ds. Okay, it is integration of 0 to infinity 1 divided by s square plus 1, s square plus 1 into ds. Okay, so this function we will get your integration formula, that is 1 divided by x square plus a is equals to, that is tan inverse of x. Okay, so this is your function. When we integrate this function with respect to ds, we will get the answer, it is tan inverse of s. Okay, so now here the limits are s tends to infinity, that is upper limit is infinity and lower limit is s, and we know already that is when we apply the limits to we will get upper limit minus lower limit here. So that's why here we will substitute that values. That is tan inverse of upper limit is infinity minus tan inverse of our lower limit is minus, yes, sorry, tan inverse of, yes, okay. So here tan inverse of infinity minus tan inverse of s is, this is your upper limit and minus lower limit, and tan inverse of infinity will get minus, sorry, pi by 2, and this remaining as it is, that is minus tan inverse of s, and pi by 2 minus tan inverse of x is equals to your cot inverse of x. So here we have pi by 2 minus tan inverse of s is there, so it becomes cot inverse of s. Okay, this one we will write here. Is our Laplace transformation of sin t by t is equals to cot inverse of s. And we have one more function is there in our equation, that is e to the power minus t into sin t by t. Okay. We take from equation 1, that is Laplace transformation of e to the power minus t into sin t by t is equals to cot inverse of s, where s tends to s plus 1. And this function will substitute s here, that is cot inverse of s plus 1. And our final answer is Laplace transformation of e to the power minus st sin t divided by t is equals to cot inverse of s plus 1. Okay. Okay. Uh, and your next problem is that is find the Laplace transformation of e to the power minus t into sin square t by t. Okay. This is sin square function is there. So solution, first we will write your given equation, that is e to the power minus t into sin square t by t. Okay. You guys already know that is your definition of property number 4, the statement of property 4, but division by t, that is Laplace transformation of f of t. So Laplace transformation of your given equation, okay, divided by t is equals to integration over s to infinity and your remaining Laplace transformation of given function, that is f of t into with respect to difference, with respect to integrate ds. Okay. So we have your problem, that is Laplace transformation of e to the power minus t sin square t by t is equals to integration over s to infinity and Laplace transformation of your remaining function, that is e to the power minus t into sin square t with respect to ds. Okay. So now we have here one more function, that is e to the power minus t. And this function you guys already know, that is e to the power t becomes s tends to s minus of a. And here we have e to the power minus t, that is s tends to s minus of minus 1, that is s plus 1. Okay, s tends to s plus 1. And this function we will write here, that is Laplace transformation of integration over s to infinity Laplace transformation of sin square t ds is where s tends to s of s minus of minus 1, that is s plus 1. This function we will write again, that is integration over s to infinity Laplace transformation of sin square t ds is ds where s tends to s plus 1. Okay. So call this as equation number 1, because first we solve this function, what we'll get in this function, on that we substitute s tends to s plus 1. Okay, here we have, that is Laplace transformation of sin square t into ds. And you guys already know that is we solved in last properties, where we have sin square of t. Instead of writing sin square t, we will write, that is 1 minus cos t 2t by t. Okay, 1 minus cos 2t by 2. So this function we will write here, instead of writing sin square of 2t, sin square of t, sorry. So here integration over s to infinity Laplace transformation of 1 minus cos 2t divided by 2 into ds. So this function we will write here once again, that is Laplace transformation of integration over 0 s to infinity Laplace transformation of 1 minus cos 2t by 2 into ds. Okay. This becomes 1 by 2 is becomes your constant value, and that's why we'll take as outside, and remaining function, that is Laplace transformation of 1 minus Laplace transformation of cos 2t. We separated this by your linearity property. Okay, with respect to ds as it is, and this function make constant value we take outside, and remaining one is Laplace transformation of 1. You guys know that is Laplace transformation constant value is 1 divided by s, right here as it is, and cos of at function is equals to s divided by, that is Laplace transformation of cos of at divided by s square plus a square. Okay, so this function also I write here as it is, that is s divided by s square plus your a value is 2, it is 2 square means 4. Okay, and when we integrate this function with respect to 0 to infinity, 1 by s, okay, 1 by s is 1 by s, integration of 1 by s is, integration of 1 by x is log x, and this remaining is x divided by x square plus a. This integration function is equals to, that is your 1 by 2 into log x square plus 4 for x square plus a. Okay, this is your integration formula that you have to remember. Okay, this function we write here as it is, that is 1 divided by s, integration over 1 divided by s will get log of s minus, and this function becomes your 1 by 2 into log of s square plus 4, where the limit is, lower limit is s and upper limit is infinity. Okay, when we simplify this function, we will get your 1 by 2 constant value as it is, log of s as it is, and you know guys, log of a to the power, sorry, m into log of a, this function will write as log of a to the power m. Okay, so here we have, that is 1 by 2 into log of s square plus 4, and this function will write as log of s square plus 4 to the power 1 by 2. Okay, it becomes our root of s square plus 4. Okay, and your, okay, wait, here. So 1 by 2 is your constant term, it becomes outside, and log of s as it is, and this function we write here, that is 1 by 2 into log s square plus 4 is equals to log of s square plus 4 to the power 1 by 2, and the limits are s to infinity as it is. And this function will write as, that is log of m minus log of n is equals to log of m by n. Okay, so this function will write here as log of s minus log of s square plus 4 under root log of s square plus 4. We will write as log of s divided by under root s square plus 4. Okay, we will write these functions here only. It is 1 by 2 into, okay, 1 by 2 into log of s divided by s square plus 4, and the limits are s tends to infinity as it is, and we want to simplify this function because of neglecting in infinity. That's why we simplify as much as possible. We will take this one, that is log of s divided by this function s square plus 4 is, will write it is, that is s square take common outside, this function 1 plus 4 divided by s square. Okay, we will write this function like this type, and this function will get log of s divided by under root s square of 1 plus 4 by s square. When we separated this square function, we will get log of s divided by s into under root 1 plus 4 by s square. Okay, here we have s square, and we separated by its root, we will get only s, and S will get cancelled, and you will get that is log of 1 divided by 1 plus 4 by s square under root. Okay, I hope you guys understand this function. Huh? Okay, we'll write this function as it is same, that is 1 by 2 into log of 1 divided by 1 plus 4 divided by s square, where limits are s to infinity. Now we have to apply here, it is your upper limit minus lower limit. That means 1 divided by 2 into log of 1 by under root of 1 plus 4 by infinity is 0. Okay, minus your log of 1 divided by 1 plus your s tends to lower limit is s only, so that's why we will get same answer, that is 1 plus 4 by s square as it is. Okay, so this function we will get, that is log of 1 divided by root 1 will becomes only 1 only, so log of 1 is your answer, this function, and minus this function as it is. Now we will separate this function, log of 1 divided by under root of 1 plus 4 by s square. So this function we will write again, log of s square plus 4 divided by s square. Okay, so log of 1 divided by s square plus 4 by s square, this function when we separated okay, when we separated your this function divided by s square from the root, then we will get s square plus 4 divided by s. Okay, so here there is no square and there is no root here, so that's why we will write here this function. Okay, here we will write this function as log of 1 divided by, okay, we will take LCM, that is s square plus 4 divided by s square, and this square and this root will get cancelled, that means log of 1 divided by under root s square plus 4 divided by s. Okay, so this function we will write as log of s divided by s square plus 4 under root of s square plus 4. Okay, so minus function is there, so minus function as it is, it is log of 1 becomes your 0, log of 1 value becomes 0, and minus of log 1 divided by s square plus 4 divided by s square, this function will get cancelled, that means 1 by 2 into minus log of 1 divided by s square plus 4 divided by only s. Okay, so now this function we will write as, you guys already know, that is log of x is equals to minus log of 1 by s function. So we want to remove this minus function, that is log of s divided by under root s square plus 4 is there. So this function we will write as positive term of log of s square plus 4 divided by s under s square plus 4 divided by s. Okay, this is your Laplace transformation of sin square t by t value. Okay, and we have one more function in this equation, that is e to the power minus t. So equation 1 becomes, that is Laplace transformation of e to the power minus t sin square t by t is equals to, this is our Laplace transformation of sin square t by t value, and this function where s tends to s plus 1. Okay, here. So 1 by 2 into log of s square plus 4 divided by s, rest tends to s plus 1. Now we substitute s value to s plus 1. That is 1 divided by 2 as it is, and log of this function s square becomes our s plus 1 whole square plus 4 as it is, divided by s, that is s plus 1. Okay, when we simplify this function we will get 1 by 2 log of under root s square plus 1 plus 2s, and our last plus 4 as it is, divided by s plus 1. Okay, this function we will get our 1 by 2 into log s square 2s plus 4 plus 1 5, that is s square 2s plus 5 under root divided by s plus 1, as it is. Okay. One by two log of under root s square plus 2s plus 5 divided by s plus 1, and our final resultant answer is Laplace transformation of e to the power minus t sin square t by t is equals to 1 by 2 into log under root s square plus 2s plus 5 divided by s plus 1. Okay. I hope you guys understand these functions all. Okay, if you have any doubts, then please ask me on through WhatsApp or something or call, whatever it is there. Okay, thank you all.